The temperature has not risen above -40 degrees Celsius in 11 days. The wind is a living force, a grinding slab of Arctic air that moves across the tundra at speeds that would strip the warmth from a human body in minutes. There is no tree line here, no canyon wall, no ridge to break the assault. The landscape is a featureless white plain stretching in every direction, and somewhere on that plain, a small group of Inuit hunters must find a way to sleep, to rest, and to survive until the storm passes. They carry no tent. They carry no fire. What they carry is something far more sophisticated. The knowledge, passed through countless generations, of how to pull a shelter out of the snow itself. This is the igloo. To an understanding how it works is understanding one of the most elegant survival engineering solutions ever conceived by human beings. The igloo is not a primitive refuge. It is not a crude pile of snow blocks stacked haphazardly against the wind. It is a thermally engineered dome, a structure that exploits the physical properties of snow, the geometry of the sphere, and the biology of human respiration to create a microclimate that can raise the interior temperature by as much as 50 to 60 degrees Celsius above the outside air, all without a single flame. To truly grasp what that means, you have to understand why snow, of all materials on Earth, is the one that makes this possible, and you have to understand why the Inuit knew this long before any physicist could have explained it. Snow is not ice. This distinction is critical. Ice is a dense, solid phase of water with very little air trapped inside it. Snow, by contrast, is a crystalline structure riddled with air pockets. Depending on the type, snow can be anywhere from 90 to 95% air by volume. That trapped air is the key. Air is one of the poorest conductors of heat in nature. When you build a wall out of snow, you are not building a wall out of frozen water. You are building a wall out of air, held in place by delicate ice crystals. An air, sitting still and undisturbed, insulates extraordinarily well. This is the same principle that makes a down jacket warm, that keeps a thermos bottle hot for hours, and that allows animals like the Arctic fox to survive in the same conditions that would kill an unprotected human being. The Inuit hunters understood this principle not as an abstract scientific concept, but as lived, embodied knowledge. They could read snow the way a librarian reads a shelf, identifying the right type by touch, by sight, and by the sound it made when struck. Before any block is cut, before any wall is raised, the hunters must find the right snow. This is called kali in some dialects, or more precisely, they are searching for a specific layer within the snowpack. Not all snow is structurally sound. Fresh, fluffy powder that has just fallen will not hold a block shape. It will crumble, collapse, and dissolve under its own weight. What the hunters need is sintered snow, snow that has been compressed and partially metamorphosed by the weight of layers above it and by the slow cycling of temperature over days and weeks. This snow has fused at the crystal boundaries. It holds its shape when cut. It is dense enough to bear structural load, but still porous enough to insulate. Finding this layer often requires probing the snowpack with a long wooden stick, listening for the change in resistance as the stick passes through looser upper layers and meets the harder, bonded snow beneath. When the right layer is found, the hunters mark it and begin. The cutting tool is called a snow knife, or pana in Inuktitut. It is a long, broad blade, traditionally made from bone or antler, though later versions were fashioned from metal when trade goods became available. The blade is shaped somewhat like a large, flat spatula, wide enough to slice a clean face into the snow, and long enough to reach the full depth of a block without the hunter having to dig down on hands and knees. The hunter inserts the blade at an angle, cuts a rectangular outline into the snow surface, and then makes a series of parallel cuts beneath the rectangle, working the blade back and forth to free the block from the surrounding mass. Each block is roughly the size and weight of a large suitcase, perhaps 60 to 80 centimeters long, 30 to 40 centimeters wide, and 20 to 30 centimeters thick. A single igloo might require anywhere from 30 to 40 of these blocks, and cutting each one is hard physical labor in brutal cold. The hunter's hands, even through gloves, grow numb. Sweat, and which is itself dangerous in these temperatures because it dampens the insulating layers of clothing, must be carefully managed. The work is done methodically, without rushing, because a rushed cut can shatter a block or destabilize the snowpack beneath it. Once the blocks are cut, the construction begins, and this is where the engineering becomes truly remarkable. The igloo is not built as a simple cylinder with a flat roof. It is built as a dome, and the dome shape is not chosen for aesthetic reasons. It is chosen because the dome is the geometric form that encloses the maximum volume of interior space for the minimum amount of surface area. This means that less of the interior air is in contact with the cold exterior walls. Heat generated by the occupants, by their breathing, by the burning of a small oil lamp called a quellic, stays trapped inside more efficiently. The dome also distributes the weight of the snow walls evenly, so that no single block bears a disproportionate load. It is structurally self-reinforcing in a way that a rectangular box of snow could never be. To achieve this dome shape, the blocks cannot simply be stacked vertically. They must be placed at an inward angle, each one tilting slightly toward the center, so that as the wall rises, it curves inward and eventually closes at the top. This is extraordinarily difficult to do in practice. A single misplaced block can cause the entire structure to shift, lean, or collapse inward. The solution the Inuit developed is to begin not at the base, but at a point slightly above it. The hunters cut a spiral into the snow around the base of the igloo, a continuous ramp that rises as it circles inward. And this spiral is the foundation of the entire structure. The first block is placed at the top of this spiral, and each subsequent block is placed next to it, continuing around and upward. Because each block rests on the one before it and on the sloping surface of the spiral, the natural angle of the ramp guides every block into the correct inward tilt. The spiral transforms what would be a near-impossible balancing act into a logical, sequential process. It is an architectural insight so elegant that it has been studied and admired by engineers and architects for generations. As the dome rises, the blocks are shaped and fitted to one another with a snow knife, trimming the edges so that each joint is tight. Gaps are sealed with loose snow packed into the crevices, a process called chinking. When the dome is nearly complete, a single keystone block, the capstone at the very top, is cut to fit the remaining opening. Placing this final block requires one hunter to stand inside the partially completed dome, holding the last few blocks in position while another hunter outside fits the capstone into place. It is a moment of genuine tension. The structure is not fully stable until that final piece locks the dome together, and until it does, the whole assembly is vulnerable to collapse. Once the keystone is in place, however, the igloo becomes remarkably strong. A well-built snow dome can bear the weight of a person standing on top of it. It can resist sustained winds. It is, in every meaningful sense, a fortress, but the igloo is not finished when the dome is closed. The entrance is a critical component of the thermal system. A simple hole cut in the base of the dome would allow the cold outside air to flow freely into the interior. And because cold air is denser than warm air, it would sink to the floor and fill the living space from the ground up. To prevent this, the entrance is designed as a low, narrow tunnel, sometimes called a pissik or saiku depending on the regional dialect, that extends outward from the base of the dome and then angles downward before turning back up to open to the outside. This creates a U-shaped or S-shaped air path. Cold air entering from outside must travel down into the low point of the tunnel before it can travel back up and into the dome. But warm air, being lighter, rises. It does not travel down. The result is a natural convective barrier. The cold air is trapped in the low point of the tunnel, while the warm air inside the dome stays inside. The entrance tunnel also serves as a place to store gear, to remove snow-covered clothing before entering the living space, and in some designs, as an escape route in case the main entrance becomes blocked by drifting snow. Inside the dome, the floor is not bare snow. The hunters spread caribou hides, animal skins, and other insulating materials across the surface to create a sleeping platform. This platform, called an itsivak, raises the occupants above the coldest layer of air, which always hugs the ground. The hunters sleep on their sides, wrapped in furs, their body heat shared among the group. A single person in an igloo will struggle to maintain warmth. 2 or 3 people breathing and radiating heat into a relatively small, well-insulated space, it can raise the interior temperature to just above freezing, sometimes even a few degrees above it. This is not warmth by the standards of a heated house. It is, however, warmth enough to prevent frostbite, warmth enough to allow sleep, warmth enough to keep the body functioning through a night that might last for weeks during the polar winter. The kulik, the small stone lamp that burns seal oil, plays a role in this thermal economy as well, though its primary purpose is light rather than heat. Seal oil burns with a clean, steady flame that produces almost no smoke when the wick, made from dried moss or the dried fiber of certain Arctic plants, is properly trimmed. The lamp provides enough light to see by and enough heat to prevent the interior walls from dropping below freezing. This matters enormously, because if the walls become too cold, the moisture exhaled by the occupants will freeze on the interior surface as frost. That frost, over time, will thicken and add weight to the dome, eventually compromising its structural integrity. A small amount of warmth from the lamp keeps the interior surface just warm enough that the moisture condenses rather than freezes, and a thin layer of water on the inside of the dome actually acts as an additional insulating layer, a thin film of liquid water that further reduces heat loss through the walls. The igloo is not meant to be a permanent home. It is a seasonal shelter, used primarily during the hunting season when the hunters are out on the sea ice or on the open tundra, far from any permanent settlement. Some igloo are small, built for a single night or a few days. Others are larger, designed to house a family for weeks or even months during the deep winter. The size and complexity of the structure depends entirely on how long it must last and how many people it must shelter. A hunting igloo might be only 2 or 3 meters across. A family igloo might be 5 or 6 meters in diameter, with a raised sleeping platform along one wall, a cooking area near the entrance, and enough space for the family to move about without constantly brushing against the walls. Maintaining an igloo over time requires constant attention. Cracks must be checked and repacked. The entrance tunnel must be cleared of drifted snow after storms. The interior must be ventilated carefully because too much moisture in the air will saturate the walls and begin to degrade the structure from within. When the weather warms and the sun returns, the igloo will eventually melt. This is expected. It is not a failure. The hunters simply build a new one when they need it, or they return to a more permanent settlement. The igloo is designed to be temporary, to be built quickly from the material at hand, and to be left behind without loss when it is no longer needed. There is no waste in this system. The snow returns to the ground. The skins and furs are carried with the hunters to the next camp. Nothing is discarded that cannot be used again. The knowledge required to build an igloo is not something that can be learned from a single lesson or a single demonstration. It is knowledge that is built over years of observation, practice, and correction. Young hunters in Inuit communities have traditionally learned by watching, by helping, and by attempting their own small structures under the guidance of experienced builders. The feel of the snow beneath the blade of the pana, the sound of a block seating correctly against its neighbor, the judgment required to know when a dome is curving at the right angle and when it is drifting too far inward or outward. These are skills that live in the hands and the ears as much as in the mind. They are passed from one generation to the next, not through written instruction, but through shared labor, through the slow accumulation of experience in a landscape that offers no margin for error. What the igloo represents, when you step back and consider it in the fullest sense, is not simply a shelter. It is a demonstration of what human beings are capable of when they pay close, sustained, generations-long attention to the world around them. The Inuit did not invent the igloo because they had no other options. They developed it because they understood their environment with a depth and precision that allowed them to extract from it exactly what they needed to survive and nothing more. They understood snow not as an obstacle, but as a resource. They understood the physics of heat transfer, of convection, of structural geometry, not as abstract principles, but as practical truth that could be shaped into walls and roofs and tunnels. They understood the relationship between moisture and insulation, between temperature and structural integrity, between the geometry of a dome and the efficiency of a shelter. And they encoded all of that understanding into a technology that could be built in a matter of hours, on using nothing but the ground beneath their feet and the tools they carried on their backs. In an age when we speak often about sustainable design, about building with the materials at hand, about leaving no trace on the landscape, the igloo stands as perhaps the purest expression of those ideals ever achieved. It takes nothing from the earth that the earth does not freely give. It leaves nothing behind when it is no longer needed. It shelters human life in one of the most hostile environments on the planet, and it does so with an elegance and efficiency that modern engineering has spent decades trying to understand and replicate. The hunters who built these structures were not surviving in spite of the Arctic. They were surviving because of it, because they had learned over countless generations to listen to what the ice and the snow and the wind were telling them, and to answer with precisely the right response.